read all that, it's all saying the same. All right, so here's another example. It has length at most 3, right? So we count up to 3, and then it has more. If you're not getting something, holler. Everybody getting that? Yeah? All right, so, but the purpose of this is I'm going to introduce you to the idea of counting mod something, mod an integer, right? You can't count arbitrarily high. So what we often do in computer science, this is a really useful thing, is usually we choose some prime number and we count mod that prime. Here, 3 happens to be a prime number. And so if you count mod 3, then you go, well, you know, most people think of mod as an operator, right? 7 mod 3, you take 7, you divide it by 3, you get a remainder of 1, right? But I'm not going to be talking about it as an operator like that. I'm going to talk about it, I live in a universe. Remember, if you're doing 2090, there are different universes. I live in a universe that only has 3 numbers. It has 0, 1, 0, 1, 2, right? And how do I count? 0, 1, 2, 0, 1, 2, 0, 1, 2, right? That's how I count. And how do I do math? 2 plus 2 is 4, but I've never heard of 4. So it quickly goes back to a 1, right? 2 times 2 is 4, which also goes to 1, right? Does that make sense? We're doing all our math in this world. Let's turn the things on, right? So here we're thinking about it not in the mod sense. We're thinking about it in this world sense, and in this world sense we can multiply and add, right? And what's kind of amazing, and we're not going to prove this today or in this course, but if you're doing it mod a prime, then I also know how to divide, right? Which is useful, right? So you can think about 1, 4, and 7 all being different names for the same number, right? So when we say that 2 times 2 is 4, well, 4 is just a different name for 1, right? They're the same object. Everybody follow that? You might want to say these are equal in the world mod 3. But we get lazy writing that down, so the mod, we sometimes stop writing it. We say at the top, we're in the world mod 3. Right? So this is just noting how to count, right? I told you already how to count, right? And how to multiply. And here's just proofs. This is all just proofs that it works. Right? If you want to read the proofs, you can go through a little hand wavy. All right, so why do we do that? Well, we could work over the integers, right? They're an infinite number. Then we could work over the reals, the complex numbers, the integers, mod a prime, right? These ones have the advantage that you can divide, right? 1 divided by 3 has no meaning, but here you know how to divide. These have the problem that we can't represent them all in the computer when they get too big, right? So this is a finite field, and we can represent it exactly on the computer. Everybody got that? And so we often do things mod, and why are we covering it here is because it's hard sometimes for poor little me to come up with examples to give you. And a big field of examples are integers mod prime. We're in the mod world. Why? Because then we can count. Right? All right, so what is this doing? There's a current value of I, right? And the I is going to change. And what do we want? We want the fact that every third character of W is a 1. All right? So if we're caring about every third character, then we have to be able to count them. And you see the example there. 1, 0 we don't care about. 1 underlined, it's a third character we care about. It has to be a 1, right? And then 0, 0 we don't care about. And then a 1, and then a 1, 1 we don't care about. And then a 1, right? So what are we doing? What do we want to remember? We've read some stuff so far. What do we want to remember? Well, if we've screwed up and then we want to remember that we've screwed up and then we're dead. Otherwise, we want to remember that we're good so far, right? And what do we want to remember? Are we on the 0th character, 1st character, or 2nd character, mod 3, right? You know what I mean? Is it if we divide the I we're on, we take the I you're on mod 3, and is it 0, 1, or 2? Yeah?
Why is it like from the first state, 0, 1, 3, you have 0 and 1 that accepts 0 or 1?
Why don't you ask questions after I've covered stuff? Do you understand what I've said so far?
Probably not.
All right. What don't you understand about what I've said? You understand counting? Mod 3? 0, 1, 2, 0, 1, 2?
Yeah.
Okay, that's all we're doing right now. All right, so when we go through, if you take in the input, I read the 1, I'm on index, I guess I'm starting it at 0. So we're going to, I sometimes like indexing from 1. So here we're indexing from 1. 0, from 0. Here we got 0, and then we got 1, and then we got 2. Right? And the 2 is the one that we care about. So what I'm going to remember is I want to remember, as I'm reading along, if suddenly I'm on an underlined thing and it's a 0, then I'm going to know we're dead forever. Right? But if we're not dead forever, I'm going to remember that we're not dead forever. And I'm going to remember, if I'm on an underlined thing, then it's going to be, my I is going to be 2, and I'm going to be in this state. If I'm on one next to an underline, I'm going to be here. And so what I'm going to do is I'm going to go around in circles. Right? So right now, if all I have to remember is the number of characters mod 3, then I go around in a circle.
So when you do like,
Let's work on only asking questions about what I've said already, because sometimes I'll say something, you might as well hear my answer before you, right? Everybody get we're going around here? All right. So now what's the caveat? If I'm here, then I know that I'm an underlined character, right? And it's better be a 1. So if it's a 1, I keep counting. And if it's a 0, I die. And if I'm dead forever. And when do I accept? I don't care how long the string is. All I care is that I haven't died. So these 3 are accept states. Everybody follow this machine? Yeah? You guys are just sitting silently. You can now ask anything about this page. Does that mean everybody finds it brilliant and I should put it on the exam? Yeah?
I'm just kind of lost because I haven't been to the last class or the class before. So that's the only reason I'm lost.
All right. Well, you probably, I hate to say it, you're probably not much more lost than the rest of them. But do you got that the machine, we're going around, we have states, right? We're always in a state. So, and this little arrow here says I start in this state. So if let's just forget this 0 here. Let's assume this 0 is coming up here. Then when I'm in this state, if I get a 0 or a 1, I'm going to read the characters one at a time. One at a time I read them. And if I get a 0 or a 1, I'm going to go over here, which tells me that I'm on a character that's just before an underline. right? And then I get a 0, 1 that tells me I'm on an underline. And then I'm on an after underline, before an underline, underline, and I go around and around. And when you're in a state, you read a character, you follow the edge corresponding to that character, and now I'm in another state. So you go around and around. And then if you're ever in this state where it's an underline and you get a 0, then that's bad. And so you go down here and you'll be dead forever. Yeah? Right? Yes, because every third character is a 1. Every elephant in this room is pink. Yeah? Oh, okay, we hadn't gotten to that yet. Everybody understand this? All right, what's a regular expression? I can have we're going along here. What's sigma? Sigma is anything in your alphabet. Here it's going to be 0, 1, right? I can take anything in my alphabet, followed by a 1. And then I can repeat that as many times as I want. Anything in my alphabet, a 1. Repeat. Right? And then, how do I end? Well, I could be done now, or I could get one more character, or I could get 2 more characters. Right? Now, you asked, could it be 2 characters? Why? Well, because this star, where is it? This star here could be 0, and this union could grab from here, in which case I get 2 characters. And we did this in the tutorial, which I know you weren't all there because there are more people here. But how are you going to do it? You're going to say star. We're going to do, actually, I guess we got union for concatenation first. Concatenation, star. And what's the star? The star is we can do as many of these as you want. Right? This is, you choose R to equal 4. And then what does each one get? Each one gets a character, a character, a character, a 1, a character, a 1, a character, a 1, a character, a 1, character, a 1. Right? And then you concatenate on that. This is a choice. Right? So I choose one of them. And in this case, I choose character. What did I choose up here? I chose 1 character. Right? What's the 1 character I chose? After the underline 1, there's a 0. Right? Everybody see that? This is a kind of a parse tree for why. In fact, what did I got? I got 1, 2, 3, 4. Hey, by miracle, look at. There are 4 underlined 1s, and that's how many I got here. That was a coincidence. Right? So you can see how this parse tree is proving that that example up there comes out of this thing here. Yeah?
So basically you're just trying to display this exact line.
Yeah. Yeah.
I'm a little bit confused about the right-hand side at the bottom. What's that?
Right hand, this down here?
Yeah.
That is a badly written sigma. Right? And what's this? This saying here, concatenation. So I have to choose something from here and something from here. And this, here I put union question mark. I don't know the grid notation here, but here we're saying this is a union of 3 things. So I get to choose which of these I want to do.
Should we show all 3 things or just show the ones that come up?
You know,
Like, should we show
I'll tell you what I would do. I would say, if the question was take this string and parse it, then it should have union this, this, and this. If I had a specific string, right, then I would the specific string uses a specific one of them. If somehow I wanted, another option is suppose I wanted to make a machine that would produce these things, then, right, I would say, right, I mean in my specific string, I'm choosing a specific R here, right? Just like I choose a specific R, I choose a specific one of the union, right? So if a question, let me tell you what I'm likely could put on a test and what I would want from you. Likely I would give you something like that, and I would expect you to write a regular expression. And then I would say, hey, let's see if you understand this. Maybe I would give you a string and say, convince me that that string's in there. And how would you convince me? You would say, well, I have a concatenation, and then the star here, I'm going to choose R equals 4, right? And then I come down here, and here I'm getting 1, 1, 0, 1. And here I'm getting 0, 0, 1, right? And you're showing me how that string fits into this regular expression, right? And when you're doing it over here, you'd say, well, I had a union here, so I chose this, which came out, right, is our 0. And then down here, you have written the entire string. Right, does that make sense? Everybody following that? Somehow I got to test you that that you're following this, right? And I think that this, if you understand this, this just is free, right? This is the meaning of it. Yeah?
When did you draw the line when the star equal to 0?
I would, what would I do? I don't know. I would say R equals 0, empty string.
So we just need to draw one case into the
Well, I mean, we could try really weird notations here about what we would do in what case, but I think what we should breathe and we should just think, we're probably not going to do anything harder than the following. I give you a string, you parse it. All right? So I give you the string 0, 1. Why? Because you really like 2-character strings. Right? And what do? You then say, here we have a concatenation, here we have a star. What am I choosing on star? I'm choosing R equals 0 on star. Concatenation. Oh, then we got a union. Which one am I choosing? Oh, I'm choosing sigma sigma. And then what does that give me? That gives me 0, 1. Hey, we go home. Right? Everybody good with that? All right. So here's a funny one. All right. This is the kind of things mathematicians love. Right? We're going to take a string. We're going to count the number of zeros in it. We're going to count the number of ones in it. We're going to take the number of zeros and multiply it by 2 and subtract the number of ones. And then we're going to take all that mod 5. And if the answer is 0, we're going to accept. Are you asking why are we doing that? Because it has a nice machine. All right? Because we can. All right? So here's a string. You count the number of zeros is 9. The number of ones is 8. You do the math. The string's in the language. Right? Everybody follow? When you've read so much so far, what do you have to remember? Yeah. Do you have to know how many zeros you've seen so far? No. Do you need to know the number of ones? No. What you remember so far is the number of zeros seen so far times 2 minus the number of ones seen so far, mod 5. Because one of the things that, let me tell you about mods you should all know. I could do math, and do a mod at the end. Or I could do the mods first and then do math. It doesn't matter. As long as your math is multiplying, subtracting, and dividing, right? It doesn't matter how you move the mods, right? So here, we might as well do the mods as we need them. So right? So if you get in now, suppose we have the r, which is the value so far, and we get a new 0, what change? How does our r change? We get one more 0, so it goes up by 2. Right? People buy that? And if you get a 1, then it goes down by 2. Mod r. Mod 5. Right? So here's the code. R is 0 through 4. What is our loop invariant? Well, we have the number of zeros so far, number of ones so far. We do this funny math. We calculate R. Right? Then if we get a 0, R goes up by 2 mod 5. If we get a 1, it goes down by 1 mod 5. Right? And then, in the end, if R equals 0, we accept. Everybody good? Anybody not good? If you're still saying, why are we doing that, let that go. Just, we're doing it. Why? Because we want to be able to do math mod 5, right? And here we're counting, in some ways, mod 5. Right? People understand the math? Here, let's do this. There's our DFA. Right? What am I remembering? I'm remembering the current value of R. Right? And if R equals 2 and I get a 0, then I add 2 to it and I go over to 4. Right? And if R equals 2 and I get a 1, I go back to R equals 1. Right? Where do I start? Well, everything is 0. When do I accept? When everything is 0. And that's it. Some of you just look like I'm ready to something bad. This isn't bad, guys. This isn't bad. This isn't bad. All right? So, let's breathe for a minute. We gotta be able to do math in our mod world. Why do we want to do math in our mod world? Well, computer scientists like it because the numbers are finite. And you can store them, and they don't get bigger and bigger, right? So if we're going to do math mod, so what is our machine? It's just a really simple machine. It's going to remember. Okay, let's have a concrete example here. All right? Your Coke machine, right? And if you get a 0, that means somebody's put a quarter in your Coke machine, right? And we're living in the 80s, so Coke is only 50 cents, right? So here, I got 1 quarter in so far. You give me a quarter. Is that right? Oh no. Here. Let's say you get a how many? What do we want? When you get two quarters. So we go back here. Let's go. We're going backwards this way. It's how much the world owes you, right? So 2 meaning, I don't know why we're doing it mod 5, but you go backwards. I put in a quarter. Oh, I give you a Coke, so I go forward 2. I put in a quarter. I go forward. Right? I mean, that's kind of a counting you want to do. Right? And the only question is, what do you do when your counting gets to be too big? And then, well, then what happens in a real computer? If I go 1 plus 1 plus 1 plus 1, eventually it comes back down to 0, right? I mean, that's what it does. Or maybe depending on the representation, it goes to some negative thing. Everybody good with this? That's what we got here, right? So here, You read it, you go in there, you read a 1, you read a 0, you read a 0, right? I don't know, you just follow this path along and we accept. Right? Now, can we come up with a regular expression for this? If you were all probably saying, I have no idea how to come up with a regular expression. Is that what you're all saying? I have no idea either. Right? I don't know how to come up with a regular expression for this. But I know it's possible because they're all possible. Right? But I just don't know how to do it. All right? So I won't ask you how to do it. All right. So here's another question. All right? So we're going to write down an integer. So 9, 2, 7, 8, 4, 1. There's an integer. And we're going to think about it as an integer base 10. And we're going to divide it by 7. Right? And we're going to calculate the remainder. That's what we want to do. Any arguments that that's a useful thing to do? Right? All right, so now the math's a little harder. Right? So we're going to be reading the characters this way. So suppose we know the answer when this was our input. This is our remainder. Right? And out comes another character, which is a 5. Right? We now get to know the answer. Right? Loop invariance. What do we have to do? We have to make progress. We read our next character, and we need to maintain the loop invariance. So we need to know the answer. Right? So what are we going to do? When we get this 5, we take our old answer here. Our old answer was 5. That's probably too low. Let me write it up here. Right? Our old answer had a remainder of R, right? And we brought in another character. We bring this character down if we're doing division, right? So now this is our new remainder, right? And what is this? This is R times 10 plus 8, right? So that's what we're going to do, right? We have our loop invariant that we have in R, right? And what do we want to know? These are all comments, right? The percentage time in my day was comments, right? Well, we want to calculate what our new remainder is, right? Well, we take our old remainder, multiply it by 10, and add on our new character, right? People kind of buy that? And what do we get there? Well, the mods can all come in. Right? So anyway, we take it, multiply by 10, and that's all we're doing here. We're multiplying by 10, we're adding C, and we're doing it mod 7. Right? And so here, if I'm on 3, and I get a 0, then 3 times 10 is 10, plus 0 is 3 times 10 is 30, plus 0 is 30. 30 mod 7 is hopefully 2, if I did my math right. Right? So here's when I added on 0. So here's when I added on, right, 0. What happened to, 1. 1 is 3, right? And then 4, and then 5, then 6, and 7. Everybody kind of follow this picture? So that's as much of the picture I drew. Right here's just doing the math. Everybody kind of buy this? Anyway, some student drew it, and I saw it on her paper, and I said, that's cool. And so I photocopied it. Does it give you any more meaning? It doesn't give me any more meaning. Everybody good? Everybody follow this? Yeah? Here, how did I get there?
How would you get there? You started like R equals 0, right?
Yeah, here. That tells you how to get there. I have to say, I've read so much, and my R happens to be 3. What do I do now? Right? In fact, what you said is kind of point that why I'm so sweaty today is that last hour I was pounding in them. You can't worry about the entire algorithm. You can't worry about how did I get here. All you have to do is trust that the loop invariant's true, that the answer so far is 3. Now what do I do next? Right? Does that make sense?